Good morning, guys. I hope it works this time. Hello, are you there? Hello? Oh, hello, guys, can you hear me?
Yes.
Oh,
Yes.
thank God. I've been trying for the past 10 minutes. I kept logging in and logging out for like 10 whole minutes. Can you hear me well?
Yes.
Yes.
Yes, we can.
All right, excellent. I don't know, was it the problem was with the connection or
But
what?
you're a bit laggy.
I'm a bit laggy. Can you hear me now?
You're a bit laggy.
Can you hear me now?
Yes.
Okay, I'm very sorry. I think something was wrong with the connection because for the past 10 minutes I was trying to log in and something went wrong every time. So I hope it works till the end of the session, hopefully. Let's hope for this. Okay. All right, guys. So yesterday we were done with finishing all the work sheets related to the rocks and minerals, correct? Till page 51. We finished page 51 too. Okay, so what we're going to do now is that we are going to start revising the electricity lesson, okay? So we're done, by the way, with the second trimester lessons. So congratulations. We are going to start revising starting now. When I see you next week, and I'm looking very much forward to see you next week. Hopefully I can see all of you. We will be doing some activities and we might go to the lab several times to I want you to try everything that we did theoretically. We were not able to try it ourselves with our own hands. So I'm going to let you try it yourself. It's going to be a fun week. Okay. Now let's start with the electricity lesson. Who's raising? Yes, Ali.
Miss, don't say next week. Stay on Sunday. It's Thursday. The weekend's next. So that means we're very, very, very close.
You just want to be very specific, huh?
Exactly.
Are you sad that you're going to come back to the school?
No, I actually hate the online because we don't have to close our cameras or get muted or anything.
Oh, don't close your
All we have to do is
cameras.
just close our mouth.
Open your cameras.
All we have to do is just close our mouth and listen to the teacher.
I never asked you to close your camera.
Yeah, I just like
But my brother, listen, but my brother, I don't know why he hates school and he loves online.
I hate online because all we have to do is just like close the camera.
I hate
when we go to school,
online
there's no such
too.
thing as closing the camera.
I hate online too because
And we
I just love
get
seeing you
disconnected.
guys. What?
Not
And we
online.
get disconnected.
Yes, and you get disconnected and you always have a problem.
Yet another reason to hate online.
Yes.
Everybody's voice lags every 5 seconds. So we can't hear anything they're saying.
Well,
but when we go to school, we can hear everything.
I love when you get back to school or I love you being in school because I love when you're in front of me. We can have fun, we can move around, we can write things on the board and we can try different activities. And this is the whole thing, the whole fun thing about the school. Anyway, it's very close. Yes, I know, dear. I know. I hate it too. I hate it too. Anyway, let's start now with the electricity lesson. I want you to mute your mics, please. So we're just going to revise over everything that we have gone through in the first lesson. We said that everything around us is made up, or we call it a matter. And why do we call it a matter? Because it has specific shape and specific volume, or it has a specific mass and specific volume. Do you remember when we talked about the matter lesson in the first trimester, and we said that anything that has mass and volume, we call it matter. Anything that has mass and takes out space, takes space, we call it matter. So anything around us that we consider matter, like the chair, like the desks, like you yourself, like everything surrounding you, consists of even smaller particles that we call, who remembers what we call the smaller particles that makes up the matter? Hey, who remembers what is the name of the very small particles that makes up the matter? Yes, Ahmed Ahmed.
Atoms.
Atoms, excellent. So inside any matter, there are even smaller particles that we call atoms. And inside those atoms, there are even smaller particles that carry charge. Some of them carry positive charge and some of them carry negative charge. Okay, yes. So the atom, inside the atom, there are two types of particles. One of them, you can resemble it like it's carrying a bag or a backpack on its back, having a positive charge, and some of them have a negative charge. Okay, now do you remember which one moved easier? Which one of the two particles moved easier? Which one of the two particles moved easier? Ruqayya, do you remember? Yes, Ruqayya, tell me.
The negative moves more easier than the positive.
Excellent, excellent. Thank you so much. So the negative is the one moving easier than the positive. Who remembers why? What is the reason that the negative moves easier than the positive, guys? What is the reason that the negative charge moves easier than the positive charge? Yes, Mira?
Because the negative charge is like smaller or
Lighter, exactly.
Yes.
Thank you so much. So because the negative charge is lighter and much smaller in size, so this makes it easier for it to move. While as you can see in the picture in front of you, you will find that the positive charge is big and like a little bit heavy, so it cannot move very easy. Now, this is the things that we said before. Now, I said to you, I told you guys that the positive and the negative charge inside any atoms act like the north and the south poles of any magnet. So you know that when the north faces the north, they will repel because similar poles repel. But if you put the north in front of the south pole of another magnet, they will attract. Okay, the same goes with the positive and the negative charge. So who would like to tell me, if I put two positive charges together, will they repel or attract? If I put two positive charges together, will they repel or attract? Where are the rest, guys? I want you to wake up. Where are you? Come on, guys. Yes, Nancy.
If you put if they are not similar, they will not attract.
If they are not similar, they will not attract.
Yeah, they will attract.
Again, so if you have like a positive and a positive charge in front of each other, they will repel or attract, Nancy?
They will repel.
They will repel, thank you. So similar charges will repel, correct? Similar charges will repel, correct? Okay, what about if there is positive and negative in front of each other? if there is positive and negative in front of each other, what will happen? Hey, Lena, can you tell me? Nancy said that positive and positive will repel. What about positive and negative? Will they repel or attract?
No, Miss, what did you say again?
Okay,
the what and the
positive,
what?
the positive and the positive charge, and I have another positive charge. I put them in front of each other. They will repel, yes. But what if I brought a positive charge and a negative charge?
Will attract.
They will attract. Excellent. Thank you, Lena. Okay, it's just the same as the north and the south pole of any magnet. Okay, so I want you guys to start answering those. Adham. Adham?
Yes, Miss.
Yes, this one in front of you, positive and positive, will they repel or attract?
Repel.
Repel, excellent. Okay, what about this one, guys? Huh?
Repel.
Yes, yes, I know. Excellent. Selim, negative and negative. Selim? Selim, are you there? Okay, Yusuf Sagid. Yusuf Sagid. Where are you guys? I hope you're not just signing in and leaving the session. Huh? Julie. Julie? Julie. Hello? I keep calling people and they're not answering back. What's wrong? Okay, Ahmed Ahmed.
Yes, Miss.
Yes, so negative and negative, it will what?
Repel.
They will repel, very good. What about positive and negative, Ruqayya?
Attract.
Attract. And negative and positive, the same, they will attract. Okay. Now, in those three atoms, I want one of you to count the number of the positive charge and the negative charge in each of those atoms. Okay, who would like to count the numbers of the positive charge and negative charge in each of those? Yes, Ali.
Okay. So the
Hey,
positive charge in the first one on the left.
yes.
1, 2, 3, 4, 5, 6, 7.
7. What about the negative?
1, 2, 3, 4, 5, 6, 7.
7, exactly. So you have 7 positive charge and 7 negative charge. And if you try to count the rest, you will find that always the positive charge, the number of the positive charge is equal to the number of the negative charge, okay? Now, Ali, I will ask you a question. The one that you counted, can I say that this atom is a positive atom?
No,
No. Can I say it's a negative atom?
no.
No, I cannot call it by a specific charge because both of them are equal. Okay, so what are we going to call the atom?
It's just an atom.
Yeah, it
Neutral,
has
neutral.
neutral. Yes, exactly. So we are going to call the atom a neutral atom. Why are we going to call it neutral? Because the number of the positive charge equal the number of the negative charge. Okay, if one of them is more than the other, then we call it by the name of the charge. Okay, and in this case, it's not going to be called an atom. This is a little bit advanced for you. In this case, we're going to call it something called the ion. okay? But you don't have to learn about this. What you have to learn about is that the atom, the number of the positive charge and the number of the negative charge inside any atom is always equal. And this is why the atom is always neutral. So if I brought a question, for you in the exam, for example, asking you, why do we call the atom neutral? What are you going to answer? Thank you, Ali. Let's take someone else. Okay. If I brought you a question asking you, why do we call the atom neutral? What are you going to answer? Ruqayya.
Yes.
What is the reason? Why do we call the atom neutral?
Because when the number of the negative charge and the positive charge are equal.
Because the number of the positive charge and negative charge are equal. Excellent. The number of the positive charge equal the number of the negative charge inside the atom. Very good. Excellent. Okay. Now, which charge do you think will move easier? As Mira and Ruqayya said, that the negative one is the one that is going to move easier. Ruqayya said that the negative charge is the one that is going to move easier. And Mira said this is because it's much lighter and smaller, and this is why it moves easier. So this is another question, guys. This might be another question that I might ask you in the exam. Why do you think the negative charge moves easier? So as Mira said, because it's lighter and smaller. Okay, now let's start to emerge in the electricity part. We talked about the structure of the atom. We know what the atom contains and the negative charge and the positive charge, and that the negative is smaller, so it moves easier, and all of these things. How is that related to the electricity? Simply, since the negative charge is the one moving easier, when we have two objects that are rubbed together, like what? Like this balloon and this piece of cloth. We start to rub the balloon against the piece of cloth. The negative charge will start to jump from the piece of cloth because the piece of cloth most probably will contain more negative charge because it's made of wool. The negative charge, since it moves easier, will start to jump and travel from the piece of cloth to the balloon. From the piece of cloth to the balloon. Okay, so this happens when any two objects start to touch or rub against each other. The negative charge is the one which moves from the object with more negative charge to the object with less negative charge. So when you rub the balloon, as I said, the negative charge will jump to the balloon, and now the balloon will have what we call a build up of negative charge. Okay, now the negative charge that jumped from the piece of cloth to the balloon left the cloth with less negative charge but more positive charge. So this is why we call the piece of cloth that it has a build up of positive charge. Okay, so again, I rub two objects together. I'm rubbing two objects together. Okay, when I do that, the negative charge will start to jump from one object to another. In this case, the negative charge started to jump from the piece of cloth to the balloon. All right, very good. Now, since the balloon have more negative charge, we say that the balloon have a build up of negative charge. Okay, and since the piece of cloth now have less negative charge but more positive charge, we will say that the piece of cloth have more positive charge. Who doesn't understand this? Is there anyone having a problem understanding this, guys?
No.
Huh? Okay,
No.
all right, very good.
No.
So the word build up, is when an object have more of one kind of charge than the other. What does that mean? It means that when an object have more negative charge, we say that this object have a build up of negative charge. So this means that the word build up is when an object has more of one kind of a charge than the other. Okay, so when an object have more negative charge, we say it has a build-up of negative charge. If it have more positive charge, we say that it has a build-up of positive charge. And this is what static electricity is, guys. Static electricity is the build-up of an electrical charge on an object. Static electricity is the build-up of an electrical charge on an object. And let me just give you a side note, just a side note, guys, that this means that the static electricity is when the charge is sitting on an object, not moving on this object. It's sitting, it's not moving, okay? Because if you remember, we talked about another type of electricity called the current electricity. And we said that the current electricity is the type of electricity that flows or runs or moves. But the static electricity is the type that stays still. All right? So the buildup of an electrical charge on one object is called the static electricity. Now, what happens when you hold the negatively charged balloon near a wall? Hey, who can answer this question, guys? Remember together, guys, remember together, when I have a balloon that has a lot of negative charge on it, and I bring it next or near to a wall, what will happen? Yes, Nancy?
It will not fall.
It will stick, right? It will stick to the wall. Yes, very good. So it's going to stick to the wall. And why is it going to stick to the wall? Mira, can you tell me why is it going to stick to the wall?
Because the balloon is negatively charged. It means like the balloon have more.
Yes, so it's going to get attracted to what?
It's going to get attracted to the wall because the wall is a positive charge.
Because yes, it's going to be attracted. It's not, the wall is not a positive charge. It contains both positive and negative charge, but
Yes.
the balloon will be attracted to the positive charge of the wall. Okay,
Yes.
it's going to be attracted to the positive charge of the wall. Now, my next question is, if the wall contains both positive and negative charge, and the balloon will be attracted to the positive charge of the wall, what will happen to the negative charge on the wall? Think about it. Huh? Now, the balloon, it has a lot of negative charge on it. It got stuck to the wall because it got attracted to the positive charge on the wall. Now, what will the balloon do to the negative charges on the wall? What will the balloon do to the negative charge on the wall? Think about it. Huh? Yes, Ahmed Ahmed, do you know?
Miss, can you re-say the question again?
All right. Now, the balloon have a negative charge, right?
Yes.
All right. So since the balloon have a negative charge, it got stuck to the wall because it was attracted to the positive charge on the wall. Correct?
Yes.
Now the wall,
Yes.
the wall doesn't have only positive charge. It has also negative charge. What will happen to the negative charge on the balloon when you bring the balloon, what will happen to the negative charge of the wall when you bring the balloon closer?
It will take it.
It will do what?
Take it.
No. Let me show you what will happen. See this? This is the balloon. We're getting it closer to the wall. The wall contains both positive and negative charge, as you can see, okay? And also the balloon, but the balloon have more negative charge, all right? Now it will get stuck to the wall because it got attracted to the positive charge. Now what happened to the negative charge?
Negative charge.
Yes, it got away, right? It's not as close.
Yes.
Yes, this is what we call the negative charge repelled. The negative charge repelled. Do you understand?
Yes.
Yes. So the negative charge on the balloon will be attracted to the positive charge on the wall, while the negative charge on the wall will be repelled because of the negative charge found on the balloon. Okay?
Okay.
All right. This is, guys, the question that we have answered in our book before. This statements, we completed them in our book before in one of the worksheets. We said that the balloon and the wool cloth, they will be rubbed together. When they rub together, the balloon will start to take the negative charge, or the negative charge will start to jump to the balloon, and then it will get stuck to the wall because it was attracted to the positive charge on the wall. How have you experienced static electricity? This is a very good question, guys. Can you give me examples of static electricity around us? How did you experience the static electricity? How did you experience the static electricity? Julie, are you there? Julie, are you there?
Yes.
Yes, okay. Tell me an example of static electricity that you yourself have experienced before. Do you remember any examples?
No.
No. Haven't you tried to rub a balloon against your head before? Or a
No,
plastic?
I only tried the ruler.
Yes, a plastic ruler, right. So this is one thing that you have tried before. When you rub the ruler against your hair and then you pull it up, you will find that your hair is sticking to the balloon, to the ruler, correct? Right, Julie? Okay.
Yes.
All right. Thank you, Julie.
Yes,
now
miss.
let me remind you of something, guys. Do you remember 2 days ago, there was another thing that we all experienced here in Egypt. That is an example of static electricity. Huh? Who knows? This is me. Okay, yes, Mira.
Lightning.
Lightning, exactly. So the lightning was something that we all experienced 2 days ago. It was a very scary noise, correct?
Yeah.
Yeah. So lightning is one of the main examples of static electricity. Lightning is one of the main examples of static electricity. All right. Another thing, guys, is when you sometimes you're walking across a carpet or something, and then you go and touch a door knob, you will feel like a buzzing feeling that goes through your hand. Some other times when you are shaking hands with your friends or touching your friends, you will feel also that you got electrocuted, right? Have you tried this before? Anyone? Yes. Yeah. So you've tried before. Yes, you have tried before that you touch something and get electrocuted because of it. Okay. Now, why does that happen? When you walk across a carpet, for example, the carpet has a lot of negative charge on it. So the negative charge will start to jump from the carpet to your body. They will start to like hang to your body. Now your body is a build up of negative charge. Your body is a build up of negative charge. So once you touch something that have less negative charge or more positive charge, now the negative charge on your body will start to jump from your body to this object. This is what we call a discharge. This is what we call a discharge. Okay, I think I'm going to end the session now, guys. All right, it's 9:40 already. I will be seeing you next week, and I'm so excited for this. We will have a lot of fun. We are going to do a lot of things with revision and with the lab and everything. So I'll be seeing you next time. Until then, I want you to stay safe, all right? Bye. Bye, guys.
Bye.
Thank you for the hearts. Lovely. Thank you.